This is a Scott flywheel. The design of the flywheel on Scott's, it was common to pretty much all the models. There are some small variations. The two speeders actually have a smaller diameter taper in the centre, and there were some differences in the overall flywheel diameter and the rim here on some of the models. Also the sprockets that are held on here, on the two-speeder, those sprockets are the same because they drive the two-speed gear. On flyers, they're usually different sizes, at least flyers with magnetos, in that we have an 1/8 inch wide one for the magneto drive, 5/16 wide for the gearbox drive. The other exception is that the later ones that ran spark ignition from points and distributor only had one sprocket. They had the gearbox side only. They didn't have a sprocket because obviously there was no magneto to drive. Distributor drive was taken off a crankcase door. So anyway, they're made out of soft cast iron. We have a taper in the centre here, and we have a keyway. The taper is obviously to take the flywheel, to take the crank. So we have a crank in both sides of there, and that gives us our assembly. We have a number of issues with flywheels over time, bearing in mind that even the youngest flywheels on Scott's are probably 60 years old. And usually the outside of them is okay, the sprockets are pretty robust. The sprockets are usually riveted on, and they have 4 or 6 rivets. Earlier ones had 4, later ones had 6. Sometimes those rivets can come loose. That's an easy fix. We're not going to go through it in this one, but generally we just drill the rivets out, helicoil it, quarter BSF, and countersink the sprockets and use countersunk screws. So that solves that one. But anyway, we'll do that in a different video. So the main problems we have is that we have a hardened steel crank that when the engines are knocked up, the cranks are knocked up, and we hammer the cranks into the tapers to get them to seat. What happens is that we have a hardened crank and we have a soft iron flywheel. Every time we knock those in, we bruise the flywheel slightly. So every single time you put a Scott engine together, you take a little bit of life out of the flywheel, and the cranks slowly move in over time. And what happens at the extreme end of that is eventually, in the centre of the taper, the cranks end up touching and they're not seating properly in the tapers. So that's one of the first problems. The next problem we get with Scott flywheels is that if the engine, when it was assembled, the cranks weren't knocked up properly, they weren't tight enough into the tapers, when the engine's running, the cranks fret, they move backwards and forwards. And what that does is that it damages the tapers in the flywheel, and there's not really much you can do with that. The flywheel taper is quite shallow, and even a few thou worth of damage in that taper, again, the cranks move in, they touch on their faces, and that's game over for that. So that's the second problem. First problem is just how many times the engine's been assembled. Second one is engine not being assembled with the cranks knocked up correctly, which means that the cranks move around in the flywheel. And the third issue is that we have the sealing glands that run in the main bearing cups, and they actually take their drive from a cutout on the keyway. And this, again, this is a hardened steel tang, and this runs up against the soft iron tang face, and this face is only, it's less than 1/8 of an inch, and the pressure of that generally over time, what happens is that the gland slowly wears a groove into the flywheel, and I'll do a close-up and show you that on this. So there's our general overview of the problems that we see with these Scott flywheels, and depending on the problems that you've got, there's a number of fixes that we've got available to do that. So we'll run through each of those and we'll show you what we do. So the issue we get is that when we get wear from the tang on the gland in the flywheel, is that when the engine's running, what happens is that because the flywheel is driving the gland round and the gland is dragging on the oil film that forms on the main cup, is that what can happen is that if that surface isn't perfectly parallel between the gland and the flywheel, is that when it's running, it'll try with the drag, it will jack the gland away from the main cup sealing face, and obviously then we lose the sealing. That's the primary air seal for the engine. So it's important that we have a good surface for that gland to run on, and it's parallel with the keyway as well. So that's why it's important to repair these. Another thing is that the groove that the glands tend to dig in the flywheel, if the gland, and I can do it on this one, I'll try and show you this. If the gland sits into that groove that it's dug, is that it's not actually seated properly in the flywheel, and this gland will go in about another 1/16 of an inch if I rotate it slightly. So when the engine's running, it'll naturally try and jack itself away from the main cup, and obviously we lose the crankcase sealing then. So it is important that the gland face in that flywheel is a good parallel surface. So the first problem we'll show you, this flywheel has suffered from this, is that if we can see where we've got the keyway here, we've got an indent at this area here, and that's been caused by the sealing gland, and again this is common on the flywheels. So if that's the only damage that we've got, what we can do to repair that, if I flip this over I'll show you. Our usual method for this is that we drill an M4 hole at an angle. This hole is about 15mm deep, and I can screw a high tensile M4 bolt into this threaded hole that we've got using some Loctite. And if I screw that in there with Loctite until it's tight in the bottom of the hole, I can then trim off this bolt and dress it back to the original flyway surfaces. So not only does that restore our surface, the other thing it does is it gives us a much harder surface for the gland to run on, and that should stop the problems. So we'll show you through that process now. We're going to do this side of the flywheel, and then we will drill out, and we will repair this other side as well, and then that'll be this one done. So I've already drilled this hole and tapped it. Here's our screw, our hardened M4 screw. I've already put some Loctite 638 retainer on this, because the idea is that this is a one-way trip, and I'm going to screw that in. It'll go in about 15mm, it'll bottom out in the hole, which again helps its security, and then I will leave that a short while to set whilst we drill the other side, and then we'll dress that back to give the original surface. Right, that's that one done. Now turn it over, and we're going to drill into this side here where that damage is. We'll dress the area back so I can get the drill in. So if we can see there, I've just dressed back a flat surface, because otherwise we can't get the drill started. So we've drilled our hole there. We'll go in now. Hope you can see that. And we'll tap that out, M4.
Romantic, isn't it?
There we are. Get a bottoming tap. Pop that one in.
Shut up and sit down.
There's a nice clean thread down there. So we'll do the same as the other side. Put on some Loctite 638. Tighten this bolt in, and then we'll leave the Loctite a short while to go off before we trim these bolts. So we're going to tighten this in. So one reason for using these Allen bolts is that we can get them nice and tight into the bottom of a blind hole. Not that it can go anywhere if it does come out. It's good practice. So there we are, we've got a bolt in each side of this flywheel now. We'll put that to one side and let's talk about inserts. Right, so if we've got small tang damage but the tapers are okay, we can use those bolts to be able to repair it. But what do we do if the tapers are damaged or bruised, or the area where the tangs run for the glands is really damaged, or the keyway is damaged, say, which is usually caused by engines that haven't been knocked up correctly when they've been run? Well, what we do in that case is that we make these flywheel inserts. So these are made out of good quality engineering steel. They're all CNC turned, as you'd expect. And what this has is it has the tapers and it has the keyway on the inside of it, and they're the standard width of the normal Scott flywheel. So if the centre of our flywheel is really damaged, what we do is we machine the entire centre of this flywheel out, obviously clock it on this outside diameter first to make sure it's running true in the lathe. We machine the entire centre of it out so it's a press fit onto these surfaces here, and we will then press this flywheel repair insert, available on our website, into the flywheel there, and we will use matching hole patterns here, 4 or 6 bolts as we said earlier, in order to secure the insert, sprocket on the outside, then the insert, then the flywheel. And so usually we helicoil the flywheels 1/4 BSF because that's the right size for the standard rivet holes in the flywheel. And by doing that we restore the flywheel to the original tapered condition. But the good news is we've now got a much harder surface as well, so this should give a much longer life. Mind you, obviously flywheel's been 80 years old, they haven't done bad so far, but you might get 100 years out of one of ours, if that's ever going to be a concern to you. So anyway, so that's the alternative. If your flywheel is beyond repair as far as the centre goes, machine it out, put one of our flywheel inserts in, and there you go, it'll be as good as new. These flywheel inserts are machined up to the standard dimensions. Obviously put the taper on the centre, the cranks will fit in like that, and being a nice tapered fit. You can see I've pushed those in with my fingers and they're stuck now. So that's the alternative. Anyway, I think our Loctite will be okay on these, so we're going to dress these bolts up and we will show you the finished condition of this, and then we can assemble this up into the engine. So here we have our repaired flywheel. That's done. You can see we've dressed the surfaces back. I've also we dressed the top surface, dressed the keyway surface, so that's 90 feet, so I was doing that with the file. Dressed the top surface with the rotary burr, and the last thing to do is to check the surface that the taper, that the crank sits on, and to do that we can simply pop the crank in and turn it round. Because the crank's got a keyway in, if there is any part of the screw that we've put in that's sticking up over that, you'll be able to feel that as a notch as the keyway goes over it. That side feels fine. That side feels fine. You can see we've got good tapers on this flywheel as well. So this one's done. I'll stick a picture up on this video that hopefully you can see now of what a flywheel looks like that's got an insert in it that we've done. Unfortunately I don't have any machine at the moment to be able to show you a video of that, but I'll do that maybe as a later one. So anyway, at least you can see how that insert fits. So the insert goes in the flywheel, sprocket over the top, and then we bolt through the entire assembly. That's how that goes together. Anyway, that's it. That's how to refurbish flywheels on Scotts.